Hello and welcome to this tutorial series where we will set up a complicated garment, bring it from CLO, here where we see it, into Maya or Houdini and then set it up using the Carbon CLO garment processor unwelded. Alright, in this video here we will get started looking at the garment in CLO, what needs to be done, what needs to be checked and how to export it. And then in next videos we will look at how to set this up in Maya and Houdini. So let's get started. So here we have a trench coat. It is already draped and we got it from the CLO store, but there's no avatar with it and we probably need to verify and set up a couple of extra things. So I'm gonna just get started and take one of the CLO avatars, which I can find in the library here. Sorry, not hanger, avatar. And then let's go to female 2 and I'm just gonna drag this character in. All right, it's going to ask me if I want to maintain the current size and avatar's pose, or if I want to use the size and pose from the garment file, which is what I actually want to do, so the avatar nicely fits into the garment. Let's press OK. All right, it's matched as well as possible, but obviously the intersections. So what I'm just going to do is press play and let it do its thing and drape this garment onto the character. So the garment is pretty high res and this might take a minute, so just bear with me and we can see how it improves. So here all of these intersections are already fixed here on the arm. We just got the shoulder left in the front. Let's have a look at the back while it's running. I think the back looks pretty well. That's all fine. Let's go back to the front and this is slowly doing its thing and fixing it up. So give it just a few more seconds and hopefully it should sort itself out. We could obviously try to go in and pull things apart, but for now, I just want to see if it fixes itself. It seems to be getting smaller, so it's probably just a few more seconds and we should be there. All right, almost there. Let's see if it fixes itself. And I think that's almost done. And ready, set, go. All right, that's pretty much sorted. Has it come to rest? Yeah, that looks nice. All right, next up, I'm gonna have a look at the tessellation because it actually took a while. Let's click at the big panel. What do we see? Actually particles in the 5. This is 5 millimeters, which gives this panel alone, if we go down to the geometry section, and you might see it 50,000 triangles. This is quite high res, and maybe you want to simulate high res, but for the purpose of this tutorial, I'm gonna slightly lower the resolution so we can just iterate faster later in Maya, in Houdini, and here as well in CLO. So I'm gonna select all the panels, and I'm just gonna go for uniform particle distance, override all of these to 10. All right, click away and let's press simulate again so it will adjust the new tessellation and put it onto the character. That's happening pretty fast, not much really has changed, so that is nice. Do we see any popping? All right, that's great. I'm gonna pause this now. Let's have a look at the panels. So for carbon in the process later, we need to make sure that none of these panels overlap. So if you go in and look at the panels, you should not see anything overlapping, which is good. I mean, these are close, but actually not overlapping. All right, none of these are overlapping. That's fine. Great. All right, next up, let's just have a look at the stitching, sorry, at the seams, the sewings. That's what I call it. Perfect. All right, and we want for a good garment to be the small or no difference between the edge lengths of the pairs. So if we go to this one, for example, it shows 0. And we can keep hovering over different ones. And it shows, I'm not sure if you can tell right now, here's 0 because we have a 152.4 millimeter edge sewn to a 152.4 millimeter edge, so 0. So we really want this first number to be as close to 0 as possible. And we can just hover over some things and we get a pretty good idea of the maker of this garment. Did they pay a lot of attention to make it physically plausible and possible so you could actually make it in real life? All right, 1 millimeter here is actually not too bad. We can keep that. We would be very worried if we had something that's way larger than 1 millimeter. Sometimes you see some that are like 10 or 15 or 20. Could be a special feature if you have elastics in it, or it could just be something that's maybe set up for some quick demos and not really a realistic garment. But here we're looking at something that could actually be made in real life. Carbon is not as forgiving as CLO in putting two edges together that have different edge lengths. So let's just keep hovering over here. We just see a lot of zeros, and I think we're pretty good here, 0, 0, 0. So it seems like this is actually well made, so we can probably just accept that it's good and stop looking at it. All right, what's next? Next up, we want to check actually some of those folds. So I've done a separate video on the fold settings. And here we have showing line type turned. So now this is a problem because turned actually does not get exported into the metadata XML file, which we need in the carbon CLO gamma processors in Maya and Houdini. The problem is when you have turned ticked, there's no information in the meta file about the status of this tick box. And it will just export the values here, which are set for the fold strength and the fold angle, which will not necessarily match the effect that turned gives you. So let's go in here and have a look. I'm going to click on the collar, and we can see the collar is turned. Now let me untick turned, and I'm just going to increase the fold strength to 100 so we can see what the default values of 180 gives us. And we can see that this actually tries to flatten out. So 180 gives us basically a flat angle, how it comes together. All right, that's wrong. Let's pause it again. I can press space to interrupt the simulation or start it again. Let's click on it again. So 180 is wrong. Let's try 0. All right, 0 is going to try to invert it. So that was obviously the wrong choice. Go back to it. And we're going to now set it to 360. Let's have a look. And there we go. We're going flat on this. And because these panels are symmetrically set up, it fixes this one here as well. So if I go pause and click on this one, we can see it is now swapped to this. All right, that's what we want. 360 is the right angle. I'm going to return the strength back to 5 because we don't necessarily need the strength 100. Okay, that's nice. Similar, let's go up to the collar here. Let's have a look at this. It's turned again. I'm going to up my fold strength to 100 and see what happens. All right, 180 degree obviously was the wrong choice because it is never the right choice when it's turned. So we have to figure out whenever we have something turned if the fold angle is either 0 or 360, and it's not always the same number. So here, actually 0 is the correct value. Just to show you, if we go back and set it to 360, we will get a wrong result. It should basically bend over like inside out. There you go, look at this. It's very obvious that's the wrong value. All right, I'm gonna set this now to 0. As we discovered, it's the right angle. Let's simulate this again, and there we go, we got the right result. All right, give it a second. And perfect. All right, I can now bring the strength back to 5, what it was originally, or I can just make it a bit stronger, depending how much you want to enforce this. But later on in the garment process, you can always adjust the strength as well, so it's not so important. All right, so we could go through the whole garment. Let me pause the simulation. There we go. We can go through the whole garment and find every occurrence of turned. So if you go here, this is off, this is on. Okay. So some it might not really be that important because a strength of 5 as it is exported will not have a big impact. So you need to decide for yourself which of these are important to double check and which ones are not. Obviously the collar and the lapel are very strong features of this code, and you definitely want to double check that you have the right values in there. Also, don't worry if you forget to set one of these to non-turned and tuned to 0 or 360. If you are in Maya and Houdini and you realize, oh, this is actually turning inside out or something is wrong with the angle, you can always adjust them in Maya and Houdini as well in the CLO garment processors. All right, for now, I'm happy with this and we can move on. I'm going to press Ctrl S to just save the scene. All right, let's export the render meshes first because I want to use the original UVs. So for the render meshes, often we actually want a higher tessellation. So maybe let's temporarily do this. I'm going to change the tessellation to 7.5, so we got more triangles. This is going to run through quickly. Perfect, and done. All right, I'm just going to simulate quickly to make sure the changes are adjusted. Everything has come together. All right, now File, Export, FBX, and I already have an old one, but let's override it, and I call it Render 3D because we're now exporting this in 3D. You might have seen in a previous video that actually we normally want our render meshes as flat panels in 2D that match the pattern layout here in the 2D window. But since we have buttons and this buckle, which I want to simulate with carbon as rigid bodies, I need them in the 3D starting position so they can be welded to the garment. All right, render 3D. Let's first save and overwrite the existing file. All right, I do not want the avatar in here. I want multiple objects and I want them thick. Make sure to not take unified UV coordinates, and I can take diffuse color combined on texture if I maybe want to use this for rendering. Let's press OK. And done. All right, now let's click on any of these. Sorry, let's select all of these, then right click and go Reset to D Arrangement. Select it. Now all of these will be in 2D. And remember, when we have them as flat panels, we need to verify the orientation is correct. So we go to thick monochrome surface, not thick. We need to make sure that they all look the same. So we have the dark side in the back, we have the light side in the front. You can also hide the stitches, the seam lines. It's one of these show threads. There we go. And they're gone. It's easier to see. So they're all white in the front and they're all dark gray in the back. So that's what we want to see. Now again, go to File, Export, and FBX. Here we already have rendered to 3D. Now we obviously need to change it to 2D. There we go. And save. Again, we don't want avatar, we want thick. Oh no, remember when you click thick, what happens is the avatar gets selected again. So if you change thin or thick, it takes avatar again. So go to thick, select, unselect avatar. Again, not unified UV coordinates and diffuse color combined on texture. All right, let's save that. Go back to 3D, where it's all come together and it's right on the avatar, because that's what we need to export the simulation meshes. Now we up the tessellation by reducing the particle distance. So let's go back to 10. Change this back up quickly. Let's sort it. Simulate a couple frames to make sure it's all come together nicely. Zoom in. And very important to make sure there's no big popping. There's a little bit here, which is probably fine. And the buttons are fighting sometimes a little bit. All right, let's stop this now. And then we need to actually fix the UVs or double check the UVs before we export it. Let's go from simulation to UV editors. Now these UVs are laid out kind of in space pretty randomly, it seems. Right click somewhere, could be anywhere. Reset UV to 2D arrangement, and it will make these UVs match the 2D pattern window. So that's what we want and what we need. Now let's go to File, Export, OBJ. Trenchcoat, and we call this Start Meshes. You could also call it Simulation Meshes, whatever you prefer. All right, I want the patterns. I do not want the avatar. I do not want the graphics trims. I want multiple objects. I want them thin. Yes, unified UV coordinates. And make sure to take Save with Metadata XML. That's what we need. All right. Also, I do not have the avatar because of the built-in CLO avatar. So let's go ahead and export the avatar as well. File, Export. I'm just going to export this as OBJ. And we call it avatar.obj. All right. I do not want the patterns, just the avatar, multiple objects, thin, that's fine. UV coordinates, keep them, I don't care. Metafile, why not? We can always delete it. Let's just go ahead. All right, and we're done here in CLO, and I'll see you in the next video where we move to Maya or Houdini and set this up. Thank you for watching.